Hello everyone. We are the UNC Charlotte Lunabotics Senior Design Team. I'm Sam Vandesandy, the Systems Engineer on the project. Along with me, I have Michael Otten and Colton Opal, who are two computer engineers, Clayton Kartner and Eric Bryant, who are the mechanical engineers, and Jerry Rivera and JT Helms, who are our electrical engineers. In this video, we will be discussing our rover for the NASA Lunabotic Space Competition held in 2020. This is our design, and we have a 4-box configuration with a conveyor belt, a rotating drum for mining, and a 6-wheel rocker bogie system.
That's one small step for man, one giant leap for mankind.
Our robot uses a rocker bogie drivetrain with a rear differential. This system allows the rover to drive through obstacles twice the diameter of the wheels while keeping all 6 wheels on the ground. The differential that connects the rockers is shown on the left. It allows the chassis to stay at an average level between the rockers and prevents tipping.
The rover's processes can be broken down into 3 stages. In the first stage, the rover will localize itself using POSIX devices located on the rover and the collector sieve. This is done so that the rover knows its location and orientation on the map relative to which side the container bin is located. 2 POSIX anchors will be located on the sieve where the diggings will be dumped, and 3 tags will be located on the rover itself. The POSIX devices communicate with each other via time of flight. That time is used to determine the distance between each anchor and tag. The rover's location and orientation are then determined using the method of 2D trilateration. This process is all relative to whether the collector sieve is located on the right or left side of the arena. In the second stage, the rover will develop a path plan based on which side of the arena the sieve is on, and the rover's location and orientation. For the third and final stage, the rover will begin its automation process, in which it will travel to the mining area, mine for the rocks, and then travel back to the sieve and dump its contents into it. And this process will continue until time runs out.
Robot's electrical system. Here's a picture of the robot. The conveyor, which I will call the front of the robot, is featured in the front of the picture. Behind the drum is a battery. These are the 4 electrical boxes. This was changed from 2 electrical boxes in the previous design. Here's a picture of our schematic. Right now the front of the robot is represented on the bottom of the page, whereas the back of the robot, with the battery, is represented at the top of the page. The 4 electrical boxes are highlighted. This box is the back left box. This is the box that mainly controls our motors for drums, conveyor belts, and other subsystems. This box is the back right box. It's home to the navigation MyRio, which controls the wheels. It also has all of the battery and ground power lines. This is the front left box. This houses the motors that are closest to the conveyor, the first wheel, and the winch to raise and lower the drum. This is the front right box. This one houses the motors for the 4th wheel and the outer drum, that is, the wheel with the scoops.
Say again, please. Houston, we've had a problem.
After verifying and testing subsystems, the team was moving to a full-scale systems test until the COVID-19 outbreak began. The team had found a way to combat working in large groups. We had set up a remote working station for our computer engineers to run their LabVIEW code. This allowed for us to test LabVIEW automation while only having 2 people present. Not long after we had prepared for a full systems test, Mecklenburg County released a stay-at-home order, bringing our project to a standstill. The Charlotte Luna competition team is disappointed we will not be able to compete in the NASA RMC this year, or even complete the automation of our rover. But the team has documented all of our work well and will be able to pass on the torch to assure Charlotte's success next year. At this point, we would like to thank our biggest sponsor, the NC Space Grant. Thank you all for everything you did, and go Niners.